In this video, we're just going to review how to simplify radicals and solve quadratic equations. This should all kind of be review from algebra. So I'm just going to show you one method, one way of solving radical equations using the idea of perfect squares. But if there's another way that works better for you, feel free to use that. In this video, I'm going to show you how to solve everything by hand, but in class we'll be giving you a calculator program known as AQuad that you can also use to simplify radicals and solve quadratic equations. So to start, we're first going to talk about how to simplify radicals. So before I begin, I'm going to be using the word perfect square a lot, so I kind of want to define that for you first. A perfect square is the product of a number and itself. So what I mean by that, so some examples would be, well, we know that the product of 1 times itself, so 1 times 1 is 1. The product of 2 and itself, 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 10 times 10 is 100, and you could keep going. So those are all examples of perfect square numbers. So when we go to simplify radicals, if we look at example 1, I have the square root of 50. I want to find the largest perfect square that I can divide that 50 by. So if we look at our perfect square numbers up here, 25 is the largest perfect square number that I can divide 50 by. I know that 25 times 2 will give me 50. So I can kind of break up the square root of 50 into those two roots, because I know the square root of 25 times the square root of 2 will give me that square root of 50. Then I know that if I think about these as two separate square roots, the square root of 25 is just 5. That 5 comes outside of the square root, since that is a perfect square number. And then I can't simplify the square root of 2, so I'm just going to leave it underneath. So if I were to simplify the square root of 50, that would simplify to the 5 square root 2. Same idea with example 2, except that I have a negative 5 out front, so I'm just going to kind of ignore that and simplify the square root of 72 the same way I did in example 1. So the largest perfect square number that I can divide 72 by is 36 times 2. And then I'm going to put the square root over both. The square root of 36 is 6. And then keep that square root of 2 underneath there. Now I'm going to bring down this negative 5, and you always multiply that perfect square number that just came out by whatever number was already in front. So I would multiply negative 5 times 6, and you would get negative 30 square root 2. So that's the final answer when I simplify negative 5 square root 72. Example 3, I just have a negative 1 out front, so I'm going to ignore that for right now and simplify the square root of 48. So the largest perfect square number that I can divide 48 by would be 16 times 3. And I know that the square root of 16 is 4. And then leave that square root of 3 alone. Bring down the negative 1. Negative 1 times 4 is negative 4. So that's your final answer. Now example 4, I have the square root of negative 16, and notice that none of the perfect square numbers are negative because you can't take a number and multiply itself and get a negative. We know the only way to get a negative product is if one of the numbers was positive and one of the numbers was negative. So this one would actually be no solution because we can never take the square root of a negative number. So that's just simplifying radicals. Okay, now let's look at some examples of adding and subtracting radicals. Now the thing you have to keep in mind with adding and subtracting, the only way we can add or subtract radicals is if they have the same exact number underneath the radical. So if I look at this first example, notice they all have the square root of 5. So when I go to add these together, I can just go ahead and add the numbers in front together, and then we're going to keep that square root of 5 the same. So first I would do 7 minus 3, which is 4 square root of 5. And then I'm going to bring down the plus 10 square root of 5. And now I can keep adding. So 4 plus 10, that would give me then the final answer of 14 square root 5. And I would always double check to see, can I simplify that square root number? So can I simplify the square root of 5? No, we can't. So we're done. Always look to see if it's completely simplified. In example 2, I have the square root of 72 plus 5 square root 8. Because I don't have the same numbers underneath the radical, I cannot just add them together. So step 2 would then be to see, can I simplify either of the two square roots? And in this case, we can simplify both, because I know that the square root of 72, the largest perfect square number I can divide 72 by, is 36 times 2. I'm going to take the square root of both of those. And then I get 6 square root 2 when I simplify it. The largest perfect square number that I can divide 8 by is 4 times 2. So then I would get 2 square root 2, but don't forget about that 5 in front, so you'll have to multiply then 5 times 2, and you get 10 square root 2 when I simplify the second one. I'm going to bring down that addition symbol, and now I'm going to see, now can I add them together? And you can, because they both have that same number underneath the square root. So I can add 6 plus 10 to get 16 square root 2 as the final answer. Now let's just say that they weren't the same number underneath the radical, then you would just leave your final answer as a sum. Okay, now multiplying, so moving on, multiplying radicals, and this includes some squaring examples. This is completely different than adding and subtracting, because with adding and subtracting, they have to have the same number underneath the radical, but with multiplying, they don't have to have the same number. So you can just go ahead and you're going to multiply whatever numbers are in front of the radical together, and then whatever numbers are underneath the radical together. So in this case, there technically is a 1 in front, and we know that just 1 times 1 is 1, and we don't have to technically write that. So we're just going to multiply then the 8 times 5, and I get the square root of 40. Now the next thing you would do is see, can I simplify the square root of 40 any further? And yes, you can, because the largest perfect square number we can divide 40 by is 4 times 10. So when I simplify that completely, I get 2 square root 10 as the final simplified answer. Now in example 2, I have a 7 and then a 1 in front, so I'm going to multiply 7 times 1 to get 7, multiply outside numbers together, and then multiply the inside numbers together. So I get 7 square root 35. Can I simplify the square root of 35? No. That's your final answer. In example 3, multiplying the outer numbers together, I get 10. Multiplying the inner numbers together, I get 18. Can I simplify the square root of 18? Yeah, 9 goes into 18, 9 times 2. And then I get 3 square root 2, but don't forget to bring the 10 down. You have to multiply 10 times 3, so the final simplified answer would be 30 square root 2. Now anytime you see a radical squared, I just want you to write it twice. So I have the square root of 11 squared. That's the same thing as the square root of 11 times the square root of 11. And now we're going to go ahead and multiply it just like we did the other ones. So I would get then the square root of 121. 121 actually is a perfect square number, and that's just equal to 11. Now in example 5, we have a square root outside of a parentheses. Anytime we have a number outside of a parenthesis, we always distribute. So you're going to distribute to the first one. So just multiply those first two radicals together. Multiplying the outside numbers together, 3 times 5, I get 15. And then the inside numbers together, 2 times 5, I get 10. And then I need to distribute it and multiply it by the second radical. So multiplying my outer numbers together, 3 times 7, I get 21. And then multiplying my inner numbers together, 8 times 2, I get 16. And then I'm going to look to see, can I simplify the square root of 10? No, I cannot, so I'm just going to bring that guy down, keep him exactly the same. And then I can simplify, though, the square root of 16. That's just the same thing as 21 times 4, since 16 is a perfect square number. And 21 times 4 is equal to 84. I can't add these together because they don't have the same number underneath the radical, so my final answer would be 15 square root 10 plus 84. Now number 6 is very similar to number 11. It's a radical squared, so your first step is going to be to write it twice and then multiply the outer numbers together and the inner numbers together. So I get positive 49 square root 4. I can simplify the square root of 4. That's the same thing as just 2. So I would have 49 times 2, which is equal to 98. In the next video, we will continue to discuss the last way to simplify radicals, and we will also review how to solve quadratic equations.